Okay, here's the first two problems in our exercise on page 228. Number one, how many ions are in 0.187 moles of sodium ions? Okay, the information that they give you, you just take that 0.187 moles of sodium ions and start your equation off with it, because that's the only information you have. That's the number we want to convert. And then our unit conversion will be 6.022 times 10 to the 23rd. That's Avogadro's number of sodium ions per mole of sodium ions. And simply cross off the moles, they disappear, and I end up multiplying 0.187 times the 6.022 times the 10 to the 23rd. I'm going to multiply that. Well, yeah, I'm going to multiply that together, and I get 7.10 times 10 to the 23rd. Notice I added a 0 to the 7.10 because our significant digits is 3, and I want to show that we have 3 significant digits in here. If I left it at 2, I'd just have 2 significant digits, and I would be understating the accuracy of this analysis. That's number 1. Okay, number 2 is done in the same manner, except we might see a little funny thing here. We're going to be having, well, the question is how many atoms are in 1.45 times 10 to the minus 7 moles, okay? This is going to be a small number, minus 17 zeros, right? So I'm going to have 17 zeros, 0.17 zeros, and then the 145. So that's a small positive number. So I'm going to take a small part of the mole. So it should be something less than a mole. Remember, the mole is 6.022 times 10 to the 23rd, so it should be some number less than that. And so I set up my equation the same way. I take the 1.45 times 10 to the minus 17 moles of arsenic. I start my equation off with that. Then I'm going to multiply it by my unit changer, and that's going to be particles per mole, right? I've got the moles in the denominator, so that will cross off. So then I just multiply the numbers out. 1.45 times 6.022, those are your decimal numbers. And then I put 2 powers of 10 next to each other, so you could easily solve that. Remember, we add the exponents. And so 10 to the minus 17 times 10 to the 23rd is 10 to the plus 6. So I end up with 8.7. Oh, I should have added another 0 here because I have 3 significant digits. So I have 8.70 times 10 to the 6 atoms of arsenic in this part of a mole. Not bad. I think I'll leave the last two for you to do.